recording. Here we go. Hello everyone. Welcome to the Data Architecture Virtual Chapter. I'm Rob. I'm really glad you're here today. We have a great topic today. My really good friend Thomas today came on. He's going to be talking about tabular analysis services, the beginning. So this is great. So here, let's start it up. So if you want to go to pass, here's a code. Please use this code. I don't know if we'll be able to give away free deal this year, but if we do, I'll keep y'all informed. I know last year we were able to give away 1 or 2 free sessions, and it was great. They were real excited. So if you're going to pass, please use the code. So pass is a really cool group of people. I mean, they have tons of virtual chapters, and here's a list of the chapters. And if you want to, if anything here really interests you, like Excel, you might want to go to the Excel chapter and check out their meetings. That interests me, and any of these topics, they're really cool. So with that, Thomas, thank you for coming on. You there, Thomas?
Not a problem. I was just finishing last bite of my lunch, and now we can get started.
Thank you.
Thanks, Rob. Yeah, thank you, Rob, for asking me to present here. Me and Rob are from here in Baton Rouge, and we buddy up for some of these SQL events. So what we're going to talk about today is getting started with tabular analysis services. My name is Thomas Leblanc, just a SQL Server dude. A little bit more about me is I do data warehouse and business intelligence architecture. I used to be a little bit like a database normalization nut. People think I'm crazy about dimensions today. I retired from being a developer about 10 or 15 years ago. My nickname on the internet universe is the Smiling DBA. I don't have a picture of me smiling there, but usually I do. And you can find me on Twitter, blogging, or Gmail with the Smiling DBA. I'm also a past volunteer. I'm currently the chair of the Excel Business Intelligence Virtual Chapter, as well as I'm on the nomination committee for the board of directors this year. And I've had the privilege of speaking at a lot of conferences, the Summit the last 5 years, and the first SQL Rally in the United States, as well as Dev Connections and Live 360 this past year. So what are we going to talk about today? We're going to just crank into working on a tabular model. We'll start with creating a project using the workspace database. We'll connect to the database, a relational database, and import tables and look at how to filter the data. Then we'll go to the dimensions and we'll look at attributes and hierarchies that you can create. We'll also look at computed columns. We'll talk about what measures and KPIs are, the differences between measures and computed columns. Towards the end, I'm going to show a display of a Power View creation of a report, but throughout the whole presentation we'll be looking at pivot table and how to report on a pivot table. What I did is I added some slides towards the end, since this is the Data Architect Virtual Chapter, about how to architect a dimensional model. So I kind of cut the reporting out a little and add some more fundamentals of data architecture to this talk. So what kind of questions starts giving you a clue that you might need to use the tabular analysis service module? Well, you might get questions from business people like, what is the profit margin by regions, by calendar year, quarter, and month? Someone might ask, can I compare the sales by color and size for mountain bikes in 2012 and 2013? Then they'll say something like, well, what happens if I remove a category to overall profits for 2012? And even something like, can I average sales, can they be tracked by subcategories over time for internet sales in the United States of America. So you start getting questions like this. The yellows are more of the dimension, attributes, and hierarchies, whereas the red are the measures that they are requesting. And dimensions and measures are very conducive to using a dimensional model. So a little sneak peek of what you might see from a tabular model. Here's a pivot table with years, drillable hierarchy years on the columns, and a drillable sales territory on your rows. And in the middle we have the gross profit margin for those drillable items. Then we might start filtering things where we're only looking at 2006 and 7 and categories of our sales, as well as maybe the gross profit for 2007 for just accessory and clothing. And this last picture shows 2006 and 2007. In the top you see that we're product categories filtered to mountain bikes, and we're just looking at the black and silver mountain bikes for those 2 years and their sales. So to create a project, you need in the tabular something called a workspace, a database. And what it'll do is it'll prompt you for a tabular instance to be installed so it can create this in-memory database while you're creating or modifying your project. You have to remember this is in-memory, so everything that you're doing is going to be loaded into RAM. That's the difference between the tabular and multidimensional. One of them is that this is an in-memory database, so you do have to either scale down the amount of data you're developing against or scale up the RAM in the machines that are using to develop, test, and even exit to deploy to production. There is an empty model that you start with. That's what we see on the screen right now. And when you connect, the best thing to do is to connect to a dimensional model. The analysis services was created for dimensional models with DIMs and fact tables. Here you can see a star schema in the most beautiful colors of the state of Louisiana, purple and gold for LSU, and then you got the purple, gold, and green for Mardi Gras. But the reason that I drew that out was just to show you why they call it a star schema. The fact table's in the middle, and the dimensions are the points on a star. So that's where that comes from. So you connect to the database. It doesn't have to be to a dimensional model or a relational database. You can actually connect to other sources. You do have to have some security involved in developing an analysis services database. The best practice is to use an AD account, and you either make that same AD account the service for the database engine as well as the service for analysis services so they can talk to each other, or you just have to make sure the security between those accounts works both ways. So when you start connecting to a database, you're going to be given the option to import into memory either a list of tables or views, or write a query to get specific data. And once you get the select views, tables, and views screens up, you're going to be having to change to a friendly name rather than the actual source table name for these connections. And then you can filter. So instead of doing a select star from a table, which all DBAs will probably tell you not to do, you can actually filter so the select statement is to specific columns of that table. And then when the tables are imported, they display just like a spreadsheet, which we'll see in just a second with a demo, which we're coming to now. And before we get that, you can look here. Here is the Internet Sales Fact kind of data diagram of the AdventureWorks database, which we're using. It's a little scaled down than the amount of columns you see on the screen, but that's what we're going to be using for this presentation. So I'm going to jump into, this is Visual Studio 2013 with the SQL Server Data Tools for BI installed. Here you see under Templates and Business Intelligence, we have Analysis Services, and there's an Analysis Services project. We'll create this from scratch. We'll create a directory for the solution. We will find a tabular instance to connect to, and we'll test that just to make sure. And it actually has a compatibility level if you're going back to a previous version of SQL Server. You'll notice this, I think in 2016, the SSDT for most business intelligence templates are going to be able to go to previous versions, which I think everybody's going to be really excited about that. So give me a second here. I'm just going to pull something out so I can see it better. All right, so we have an empty model, and we're going to import some data. If you click on the model BIM file, you do have some properties. There's some properties like workspace retention and workspace server. So you can unload from memory, keep in memory, or delete the workspace as you're doing the development. If you right-click on the project and go to Properties, this is actually where it's going to be deployed to and what the database name is. But because we're creating this in memory, there's actually a temporary database on our analysis services instance, and we'll look at that in just a second. So I'm going to say import from data source, and I'm going to select from a SQL Server database. I am specifying the actual database instance and what database I want to pull from. Again, this is an AdventureWorks database that's kind of been scaled for this presentation. And then as I click Next, it's going to prompt me for impersonation information. So I could put an AD account with a name and password here if I wanted to, or the better option is just using a service account. That way the service can talk to between the database engine and the analysis service engine. We'll select from a list. We're going to get our related tables in that database. A very easy option is just to go to the first fact table you want to bring in. You check it and you can click select related tables, and it looks at the foreign keys and then populates the rest of the tables based on that. We're going to take the dim product off. The dim product in this database is for a star schema. This one with SF is actually a snowflake, which I want to show you some information about using snowflake schemas. We're also going to get the product subcategory as well as a product category. Again, you can give it friendly names, so rather than dim customer or dim date or dim product category, I can go in here and it's not changing the name of the table, it's just changing a friendly name. I can actually remove a dimension if I don't want it involved. In this tabular model, I can put spaces between some of these names. And then the last thing is I can click on this preview and filter button and be able to remove say the promotion key from the select, as well as the extended amount and unit quantities and these blank carrier and PO numbers. So I can kind of scale down what's being selected for this. You could even roll down one of the columns and filter as well if you'd like to. But I'm going to do that for each one of these just to make it a little more viewable. Take out maybe the ID that's related to the natural key of the table. Do that for subcategory. Oops. Oh man. Didn't want to, I accidentally click select related table. So let me clean this up real quick. Good thing I already renamed them. And take promotion off. Alright, so subcategory, preview filter, take that ID off. Product. Here's an interesting one because product is a slowly changing dimension, so it actually has a status, an end date, and a start date, which we don't use to display information to our end users. They're used more internally for this. We might also want to take some of these attributes off that don't have any values, and we'll leave the rest and click OK. Do the same thing for category. I'm just going to take the natural ID hierarchy off. And of course, in every dimensional model, you have a date dimension, and we'll remove the semester column and maybe the week number of year and maybe the day of year. So here you just see that we can filter things. Same thing with customer. So a lot of columns and customers. So I might want to take out some of the demographics, some of the ranges. There's actually a geography key I don't need. There's 2 states, there's a code as well as a name. And just to make it a little more viewable, I don't want birth date. I'm not going to want to display personal information about the customer in this reporting module. So I'm done. I click Finish. It actually imports all these into this workspace database. I'm going to go ahead and close this. And now our empty model is now full. Again, here is the tabs for each one of those tables. dimensions as well as fact tables. If I go up to the model menu choice, I can go to Analyze in Excel, and I can see what's been built. You notice we haven't deployed anything yet, but yet we're able to do some slicing and dicing already just because it's in memory and it's been promoted to a workspace database. So I'm going to launch SQL Management Studio, SQL Server Management Studio, and we're going to see what was created. So I'm going to go to that Analysis Services instance, go to Databases, and you see that Demo 2 now has a GUID on it. So this is that temporary workspace database, that's the in-memory data we're dealing with. If we go back to the model, right-click on Demo 2 and say Deploy, now it's actually going to deploy the database. So as we look in our Management Studio and we refresh databases, now we see Demo 2. So this is your workspace, which SQL Server manages, but this is the one that actually gets deployed. So you can be working and have something deployed, say to dev and test, that is different than your current development. Just like to show that at the beginning to so people can understand how that is created and works. Okay, so we'll go back to our slides. And that's our first demo of creating a tabular model. So real quick, we were able to do something inside of Tabular in like 10 minutes. That's why I guess they say it makes it easier. So the first thing we're going to tackle now that we've imported our tables is we're going to look at the dimensions. These are the things you slice and dice by, which is really filtering and grouping, slicing and dicing. But you got to take into account some attribute properties, and the first one is you have to find your date dimension, and you have to actually set it as the date table. And we're going to look at a demo of this. It's got to have a unique date data type column as well as being unique throughout all rows. And that we'll also look at creating a hierarchy of our year, quarter, month, day, and we'll see how we can order the month name instead of alphabetically by a number. So again, as my friend Patrick Leblanc would say with SQL Lunch, no fluff, just stuff. We'll go straight back into the demo, and we'll go to the Date tab. And if we go up to the Table menu choice and go to the Date submenu, there's a sub choice for Mark as Date Table. We'll select that and see, and Analysis Services actually figures out which column is a date type and which one's unique for you and selects it there. If you can't find it, it's going to be blank, but you definitely need that so it can create these time intelligence type functions. So I've marked it as a date. I'm going to go to my diagram view in the lower right. You can see the you can see over here in the lower right there's a diagram and a grid view. We'll go to the diagram view. And here we'll see, because of the foreign keys, that there are relationships between the tables that we imported. Subcategory and category to the product, which is our snowflake part. Here's our internet sales fact table. And here's our customer dimension. And we can reshape these so they look a little better on screen. And then lastly, or firstly, is our date dimension. So a lot of these names that it gives here, we don't like, so we can actually rename it. So first thing I'm doing is right-clicking on Date Key, and I'm just going to say Hide the Key from the Client Tools. The next one I'm going to rename just as Date. I'm going to hide the number of week. I'm going to hide the date name of month. I'm going to rename this as Day. Rename English month name as month. I'm going to hide the month number of year. Rename calendar quarter, quarter, and calendar year as year. You might also have a fiscal year, quarter, month as well, but this is just a calendar one we're looking at today. So I'm right-clicking on year, and I'm going to say Create Hierarchy. It's going to ask me for a name. I'm going to give my new hierarchy YQMD. Right now it just has year in it, so I'm going to right-click quarter, add to hierarchy, right-click month, add to hierarchy, and then right click date and add to hierarchy. Now, because this is in memory, if I go back to Excel and I do data, refresh all, what you'll notice over here in the date dimension, it's going to change. So now in my date dimension, I see my year, quarter, month, day hierarchy, and I also see the more fields, they're renamed, and those numbers I hid are no longer available to me. So that quick change right there has helped us with the date. Now if we drill into year, quarter, we see that the months are not sorted properly. February, January, March. So if I go back to my design and I go to the month attribute, there is a sort by column, and I could change that to day number of the month. Oops, wrong column. Actually, month number of year. And now, go back and refresh. You'll see February, January, March change to January, February, March. So that's our date dimension. And that's a demo of what you can do to format the date dimension so it's more appealing to your end users. So now we're going to look at the other dimensions. The first one is customer. We have a first and last name. We're going to combine those to give us a customer name. We'll look at sales territory, which has no label for its key. It's the group, country, and region. And then we'll look at the product dimension before we look at measures to see the snowflake, what that means, and then also to see what's slowly changing in the product dimension entails. So again, no fluff, just stuff. Let's go back to our design. We'll go back to the grid view, and we'll go to the customer dimension or table. In here, I can go to add new column, and I can create a new column. I'll start with an equal sign, and I'm in the middle part, kind of like an Excel function, basically. And I'm gonna start with a bracket, and that's going to give me a list of all the columns in this table. If I wanted to reference a column in another table, I would start with a single quote, and it would give me the table name, then bracket column name. But since we're in this one, I can use the IntelliSense to help me design a new column. And basically, this is my last name, comma, first name. If I don't get an error, I actually get the value in that column. I'm going to rename it as my customer name. And after I do this, I can go to the columns over here, highlight some multiple columns, and hide those from the interface. I also have a hierarchy in here, so if I wanted to for customer, I could come over to customer, right click on, I'll rename this just country, rename this state, and I can create me a country, state, city hierarchy. So we'll call it customer geography. And I can add my state, and then I can add my city. Alright, so we'll go back to the grid view, and we'll go to the sales territory. And here we have the group, the country, and the region. So if we just gave the user a freeform drag and drop of these, they might put country on top of group instead of country under group. So the best thing to do is create a hierarchy for these three. And what we'll do is we'll start with group, and we'll just call this territories. And then we'll add country to there, and then region, and now we can hide those other three as well as the key, and they only see the territories now. So that's our sales territory, and the last one is product. So product is related to subcategory, is related to category. So we can have those as three dimensions, but if we wanted to, since this is a snowflake, we wanted to put them all in one dimension to create a hierarchy, we can actually add a column. Here we can use the related function. Excuse me a second, I'm going to turn off my email, maybe even the Skype. Oh, I can't do that just yet. All right, I'm sorry. So here I can use the related function to say go get my category name from the category table. And since product, if we go to the grid view, since product is related to category, subcategory is related to category, I can actually pull that category name into my product dimension. We can also hide the keys if we wanted to, where we just see the names. But I'm going to go back to my grid view, and that's my category column. Now I'm going to rename this category. But what you notice here, there's a bunch of blanks before we actually get to the values. And it looks like I grabbed the key instead of the name, so let me make sure I get the right column here. Name, there we go. So because the product subcategory key can be null in this case, the category could be blank. So I can actually put some more logic in here. I'm going to copy this. I could say if, open parentheses, that category name equals kind of an empty string, I can say put unknown, comma, else, use the related value. So let's see if that works, and we don't, yeah, there we go. So now I've got a category of unknown, and I can actually do the same thing for subcategory. If related, sorry, someone's pinging me here, related subcategory name equals the blank. I could put unknown, else, related equals blank, unknown. Let's see, something's not working there. So let me just do related subcategory name. Make sure that works first. Yeah, so let's rename that to subcategory. Now let me add some more logic to there. So if this related equals blank, I'm going to put unknown, else I'm going to use the subcategory. So that's how we're able to use what's called DAX. DAX is the kind of the programming language of the tabular model. MDX was the language for multidimensional cubes. And this is some DAX language. If you have error testing, related functions, there's a bunch of different functions that you can use. This is just some of the examples. Now again, as I'm cleaning this up, I can rename some of my columns, like this is product ID. Now that I have category and subcategory in my product, I can also hide the actual tables. So here I'm going to the table on the bottom and actually hiding it from the client tools. If I go refresh my Excel spreadsheet, you'll see now that we don't have the category and subcategory. We also have this sales territory hierarchy. We also have the customer geography hierarchy, as well as the product. Well, we haven't created that one yet, so let's go back to the grid, and we are going to go to the product table. Move the internet sales down. So you can kind of format this the way you want. It's really nice. So we'll create a new hierarchy called product by category. It's got category, but we'll add subcategory, and then we'll add product name, which here we can just call this product. You also notice I can rename it in the hierarchy, but yet it still retains the name in the actual column, which here I could just say product name if I'd like to. So there we go. Let's refresh this guy, and we'll see we have a product category hierarchy. So we're moving along. That's good. And let's go back to our slides. So that was a demo of the dimensions. We cleaned up the product subcategory category, we did the customer as well as the sales territory, and we have a date dimension so we can use time intelligence. So that's about 30 minutes into this, 90 and 30, and we pretty much have everything except the measures and even some KPIs. So inside of the tabular, you can create sum, min, max, averages. There's a neat little toolbar to be able to quickly do that. To a column is also time-based, so since we flagged that date dimension as a data type, then it's going to let us do year-to-date, quarter-to-date, previous period, next period, use a bunch of time intelligence functions. Really neat thing is being able to create KPIs. These are key performance indicators. You have a value as well as a target, and it gives you a gauge for performance. It could be another measure is the target, or you can just put a default value in there. So one of the questions you hear a lot is what's the difference between a computed column and a measure. A computed column actually gets stored in memory, and it's going to be a formula for each line or each row in your table, whereas a measure is going to be some sort of aggregation at the full table or whatever context filter you're dealing with. So in the left part, we have line item margin, which is sales minus cost. But in the bottom, we have internet sales for the whole table or the whole tabular model, and it's the sum of the sales amount. Gross profit margin is a good example for doing analysis for a KPI. Here we're taking the sum of the sales minus the sum of the total product cost, and together we divide that by the sum of the sales. We give it an absolute value, something to compare it to as a margin. Then we have an upper and low. We can have 3 values, or we can have up to 5 values, either 3 or 5, and there's different indicators for each one of those. So again, no fluff, just stuff. We'll go back into our tabular model. We'll go to the grid view, and we're going to look at the internet sales. Now, the first thing I'm going to do is a computed column. I'm going to say equals sales amount minus total product cost. And that is really my gross profit on each line item, which I must have did something wrong there, equals instead of minus. And then I can rename that column to gross profit. So now you're able to see the gross profit on each line item. While we're in here, we can hide some columns. Even the quantity as well. We'll hide those columns. We can go down below the quantity column to the measure section, which is the first in many rows after the data, and we can go up to this toolbar to take some sort of aggregation. Here we can say, show me the average quantity. So here we can create a measure called average quantity sold. We can also do a sum for product cost. This is our internet cost, and then we can sum up a row. This can be our internet sales. All right, so now we have some measures. If we go refresh our Excel spreadsheet, we'll see now in the upper part, we have some measures. So instead of having this no measure defined, we actually have internet sales. And now we're slicing by region, country, group, country, and region. We can see the individual sales for accessories, bikes, clothing. We can even drill into bikes and even into mountain bikes and see that information. And we have cost and average quantity sold. So now let's look at something else. I'm going to zip this up real quick. I'm going to move my territories and product categories, and I'm actually going to drill into the bikes. So my bikes, mountain bikes, and I could see a list of bikes. I didn't show this in the product dimension, but there is a slowly changing dimension, which means that there's more than one row for some of these bikes. I'm going to go to the product and add list price. And now I am going to scroll down in my list, and eventually you'll see that one of these mountain bikes has 2 list price. So what it has done is, because of the slowly changing dimension, that the list price is unique per row, the actual product name is not. So here you can see an example of the slowly changing dimensions and its effects in reporting things. So we can see at one list price that this is what we sold, and at a second list price what was sold. If we want, we could add that start and end date back and see when that range of values took place. It's obvious we have more in the higher value than the lower value, but that's just really over time. So that's an example of a slowly changing dimension. I'm going to take that off and go back to our design, and now we're going to look at the gross profit margin as well as a KPI. So I'm going to go to a new formula, and I'm going to say internet GPM equals, so I'm just giving it a name, and what here I want to do is the sum of my sales amount, remember that formula, minus sum of total product cost. I'm going to divide that by the sum of my sales amount. Now I shouldn't get an error there. Yep. And you notice here my gross profit margin is now a decimal. I can go to format and I could change that to a percentage. So all these measures have properties, and they inherited at this time what was above them. So for the dollars, we already had currency, but because we created one from scratch, it didn't have a format, so we added percentage to it. And you can see it formatted it rather than a decimal to an actual percent. If we right-click on that, we have a Create KPI. I'm going to compare it to an absolute value. I'm going to say 0.412 as my absolute value. My lower value, I'm going to put 0.408, and my upper, I'm going to put 418. And I'm going to pick some display characteristics of it and click OK. Now if I go back to Excel and I refresh this, I'm going to drill back up, and instead of having internet sales, I see this new little KPI area. And so here I can look at value, goal, and status. And so you can see the 62 for accessories is above my goal, which turns it green. Overall, I'm pretty much just below what I want it to be. And here I'm farther below the red indicator than what I want my sales to be. So that's a demonstration of measures and KPIs. The last one we'll look at is year to date. So we'll say internet sales year to date. It's going to be, the function is called total YTD, and it's given us some IntelliSense. So it's asking us, what do we want in the expression? We want internet sales. The next thing it says is, what is the date key? It is date. It's not the date key, it's the date of the date dimension. So here we did a year to date. It's not going to give us anything for here because there's no context for it. But if we go back to Excel and we remove our KPI, and instead of territories we put YQMD, and we add, did I refresh this? Refresh. Yeah, so internet sales year to date, and it's actually not a dollar, so we'll change it to currency. Remember, we're doing this all in memory, so every time we make a change, it actually refreshes the memory database. So here's our totals for 2007. So if we drill into 2007, we'll see that for each quarter, we have a different value, but it's showing the actual. So let me put internet sales next to it. So my internet sales here, let's get rid of accessories. Just look at bikes. So our sales are 1.4, 1.6, 2.5. Well, our year-to-date sales is accumulating that as we go through each quarter, as well as every month in that hierarchy. So by flagging that date as a date type, we get those type of characteristics where we can use functions like year-to-date, month-to-date, quarter-to-date, previous period, and then we can start measuring things like growth year-over-year, growth period over period. All right, so that was our demo of the measures and KPIs, we're really practically finished in about 35 minutes with creating this from, and it's because we had this as a dimensional model that works so well. But there's some other stuff. There's perspectives, there's partitioning, and there are roles. And we're going to look at each one individually. Perspective is kind of like a table view, so you only see certain things about the dimension and facts. Partitions let you process data independently of each other in facts to help speed up the processing part. And there's roles where you can do security. So you can tell, and we'll look at an example of North American sales. Well, that's the only sales that a person can see based on a role. No fluff, just stuff. We'll go straight into the demo again. We'll go to Model and Perspectives, and we'll create a new one. I'm going to call this one Customer. And for the customer perspective, we're only going to show customer, date, and the internet sales. I'm creating one called Sales Territory. And here I can display date, sales, product, and sales territory. So now when I go Model, Analyze in Excel, I can actually pick a perspective. If I pick one of these perspectives, what you'll notice is in the available field list, I only see those things that's been selected. Now we selected straight tables here, but you can even drill down to an individual attribute level if you like. Just like a cube, a multi-dimensional, it has the same thing. The next thing we'll look at is the processing, which you can do by partitions. You go to Internet Sales, Table, Partitions, and then you get a nice little screen here. So what I'm going to do is I'm going to make a copy of the existing one, and I'm going to say Internet Sales less than 2008. And what I can do is over here, I can look at the query editor. Here's my from clause, and I can go find the date column, which is order date key, and I say where that value is less than 2008-01-01. There's a validate button. So now I have a partition for all my data that's before 2008. I can go back up to that original one, look at the SQL, and put a where clause on it. And I can say that's my current stuff. So I'm going to say greater than 2013-01 or 202-1231, and I'm going to call that Internet Sales Current. I can validate that, and I can make another copy of this one and call it, in between. And I can say where the order date between 2008-01-01 and 2012-12-31. So what did I call the current? Did I overlap here? So greater than that. So that's everything 2000 above. So all those validate. I'm going to click OK. And if I go up to table or model process, and I say process all, let's see if the internet sales, what it processes. So 334,000 rows. But if I go back to my table partitions, you'll notice that it's divided in this number of rows column to the different types. So less than 2008 had 28,000, in between had 251, and the current one had 54,000. So I can create these partitions, and if no new data, only new data is in the current one, when I go to process, I can tell it process partitions and just say current. And that way I don't have to process any of the old data, which speeds up the time window you have to deploy new data. All right, the last thing we'll look at here is roles. And here I can create a role like admin, and that person is an administrator. And then you can actually add members to it. So you can add 80 accounts to that role. I can also call one sales, make it read only, and I can add members to that. But in my filtering, I can go to sales territory, and I can say sales territory, and this is country equals United States. So here I developed just a little DAX statement. Click OK. And to test that, I'm going to go to Model, Analyze in Excel. I could tell it add a role. Click OK. And what we should see is when we drag out sales territory, you should only see North America, United States, and those regions. So that was a quick perspectives, roles, and partitioning, which is some good administrative functions. I'll go back to my slideshow. Inside of Excel, you can actually connect and do a Power View, which is a precursor for Power BI, and you can take a look at how to make some, quote, pretty reports with connections to a tabular model. There's many, many functions, but I'm not going to do that. What I'm going to keep doing here is I'm going to continue, since this is a data architect virtual chapter, is what do you need to know in order to architect one of these dimensional models? The first thing, let me get a sip of water. First thing you want to look at is a lot of reading material. There are two gentlemen, Iman and Kimball. Kimball's retired now, but I've seen Iman apparently at some SQL Saturdays lately. I'm more of the Kimball Data Mart design way of doing things. I've never done Iman, so I can't criticize them or promote anything from there. But what you have to remember is BI stands for business intelligence. That means that the business is intelligent, whether we think so or not, from an IT perspective. They're not just reporting things. You're going to have to start working very, very closely with the business and what their matrix are. You're going to have to develop some skills where you can communicate very well with people in the business section. You need to know the difference between a data warehouse and a data mart. You really, in the Iman area, you start with a large data warehouse, whereas in Kimball, you build individual data marts and they become your data warehouse. There's even something today called Data Vault, which I'm starting to read about, and it's interesting, and it seems like a very valid way to do things. So some of the skills you need are data modeling skills. Let me put this little picture up here for you. Here is a Kimball spreadsheet I'm using currently to document the dimensions as well as the fact table. This is a free spreadsheet from the Kimball group, and you can actually get a quick little design. So you're going to have some documentation skills as a way to data modeling. What we looked at with Tabular is kind of the precursor of doing analytics. We saw gross profit margin computed in there, and you really could take any calculation you want and place it in a tabular or a cube. There's lots of requirements gathering that you're going to have to do. In the data modeling world, you'll learn the difference between a transaction processing than an analytical processing database. Here you see a picture of the bus matrix used for the AdventureWorks, where the customer, date, reseller, and product are the dimensions on the rows, and then our columns are the measures, and there's check marks if that particular measure is related to that dimension. There might also be something called an operation data store, kind of a temporary place for data, archival data, before you create the analytical processing or dimensional modeling. You might also have a staging area. This is where you archive from the transaction. It's a source of your data warehouse and data marts. It might be even just an area where you temporarily place things in the transformation stage of ETL. So again, the transaction processing is a lot of getting small chunks of data in and out. It's operational, which means less rows and indexes and very light reporting. But you do normalization inside of a transaction system, which means no duplication. When you move over to the analytical side, there's a lot of data, a lot of indexes. Duplication of data is okay. Don't be scared by it. And you might hear some things like cube processing. The latest things in the latest versions of SQL Server, as well as other relational and other types of database, is in-memory stuff. So in-memory is really building up a lot of steam. I even use column store indexes currently at work, so those are pretty neat things. So when you do dimensional modeling, there's a thing called conform dimensions. Conform dimensions mean that a product dimension might be related to multiple fact tables, and you're trying to conform the attributes of that particular dimension. All dimension tables have surrogate keys. It's different from your natural key or your business key. It's usually an integer for the lookup, and you also create it for the slowly changing dimensions. Don't worry about normalizing data in a dimensional model. Duplicate data is okay. And you always want to have names and descriptions for codes. Don't just use codes for reporting. So use something that might be 20 to 30 characters long, not something like 100 to 200 characters. But you need something more than ABC-01. If you want to get really good at dimensional modeling, you'll learn something about a bridge table, which talks about many-to-many relationships. If you go to SQLBI.com, they have a great white paper on the evolution of many-to-many. So we saw the date dimension. All models in a dimensional model have a date dimension. That's why we picked it first in this demonstration. You know, the star schema we saw, all the dimensions are related to the fact, whereas a snowflake, some dimensions are referenced through other dimensions. So here's our star schema we saw earlier, and then the related dimensions for the snowflake are like the subcategory and category to the product dimension. In the AdventureWorks database, there is a real good example of geography being referenced through reseller for reseller sales and through customer for internet sales. It's a really good example of using a reference type dimension. So what is this conform dimension? If you notice here in our picture, we have a product surrogate key and our sales fact, inventory facts, and inventory flow facts, all different types of fact tables, all have that same product subcategory, product surrogate key related to them. So product is conformed between these three facts. When you develop facts, you're looking at granular measures. There's three types: transaction, which is like a line item; snapshot, which is like inventory; and period, which is like taking a snapshot or accumulation of what the bank balance is for someone, so you can compute interest at some point in time. The columns and the facts are the surrogate keys that have been related through the dimensions. You'll see measures like quantity sales and even count of rows, which is usually done in the reporting tool. And there's sometimes a natural key, primary key, like the sales order number and the sales line number. So facts are denormalized. The example of internet sales is a great example. Here we have a sales order header and sales order detail in our transaction system, but in our fact table they're combined together with surrogate keys for the dimension. So don't worry about this denormalization. If you're from a normalization world, it is okay. And probably the last thing is the ETL part of, so once you, about 70 to 80% of your time is spent in ETL. ETL is extract from the source, transform to formulate it for reporting, and then load it into this dimensional model. Integration Services is the tool from Microsoft. It used to be called DTS. I was real animate about not using it, that I was a hardcore SQL Server developer, but once I tried it, I liked it, and I use it every day today. You can still use your existing T-SQLs. You can have them inside of components, and you can have them actually step through and run store procedures if you want. So you're not limited to just using the components inside of SSIS. So remember, analytics is like what we looked at today. There's a cube version as well as a tabular version. If you're not using analysis services, there's some Windows functions for your reporting. There's plenty of them available today to do the analytics inside of your T-SQL. If you're doing it in reporting services, it's going to be a little bit more difficult. The nice thing about cubes and tabular is you actually centralize these measures. So the calculations, if you're repeating them in T-SQL as well as in reports and not centralizing it, it's very likely that you're going to have problems with some of the numbers reported. So by using analysis services, you can really centralize that business logic or business rules in one place. Then once you relate them through like conform, the slicing and dicing or the grouping and filter becomes much easier. There's two versions, and you'll see a lot online about them. Multidimensional is mature and works really well in enterprise. Tabular, as you saw today, is a very simple and quick way to build out a system. But it's growing and growing with each new version, and new features are being added. It's just not at the maturity level of multidimensional. So I'd like to thank you for your time, and we'll move on to questions now. But again, if you need to contact me on Twitter, I'm at the Smiling DBA. You can look at my blog, which is really thesmilingdba.blogspot.com, and you can email me on Gmail, thesmilingdba@gmail.com. So now we'll go ahead and take questions. And I think there's one question or two questions ready to be queued. You want to go to that, Rob?
Sure. So the first question is, could you give the name of the Kimball DIM data model spreadsheet name?
Yeah, good question. I had this at a talk the other day. Let me see if I can find that spreadsheet. Kimball Group. See if I can get this up. So if you go to the Kimball Group and you go to books, which they're retired, by the way, there's a new DecisionWorks is the company. So the Data Warehouse Toolkit, 3rd edition, there's a resource section right here. If you go to the book, towards the bottom, Tools and Utilities, here's your sample date dimension spreadsheet, and then somewhere around here is also the one for, this might be in the Life Cycle Toolkit, is that spreadsheet, yeah. So requirements gathering. So chapter 3 of the Data Warehouse Lifecycle Toolkit. So here you can go and get all the resources that are free from the Kimball Group.
Great, thank you. The other question is, they're asking if you could talk just a little bit about the tabular model scripting language they call TSML.
All right, so what I can tell you what I know as far as it's changed. I don't know the scripting language. They say it's more like JSON. And inside of the analysis service world, there was an XAML language, which was the scripting language. So from 2014 to 2016, they changed the scripting model for tabular and not multidimensional. So I don't know the details about the scripting, but once you get 2016 installed, and say for instance here, I'm in here and I want to process the database. If I click on Process Database, there's a button up here that says Script. If I click Script, it's going to show me the script to process it. Now this is XAML, which is 2014 version. So 2016, there's a new language, so this scripting is going to be different. And that's about all I know about that for now.
Okay, great. And that's all our questions. I just want to say that the session was recorded and we'll put it on our YouTube channel, and you know, if you want to go back and watch parts of it, it's there for those for any reason, or share it with friends. And thank you, Thomas, for coming today.
No problem. I'm glad you invited me, and that was a quick overview of dimensional modeling as well as tabular.
I'll send out a link of the video. I'll put it on our past website, and you can always go to SQLtigers.com. I'll put it on there too, and you know, and if you have questions, you can send me questions or send Thomas questions. I'll make sure Thomas gets them.
Yeah.
So, all right. Well, Thomas, that's it. So thank you again, and
thanks, Rob.
And we're just going to shut it down now, and y'all have a great evening and a great weekend. It's Labor Day. So, I mean, more day. So, thank you.
See ya.
All right, bye.